سلام علیکم. امیدوارم که حال احوال شما انشالله خوب باشه. I hope you are fine uh, and good health inshallah. Uh, this is the another session of the advanced database. You know, in the previous sessions, we talk about uh, distributed systems because the distributed systems is the infrastructure of advanced database. Um, okay, we define the distributed system, some goals of distributed systems, and some types of distributed systems. One type of distributed system is distributed computing systems. Okay, the cluster computing, grid, grid computing, and cloud computing are three types of systems which belong to the distributed systems. Uh, okay, in the previous session we talked about the cluster computing. After that, the grid computing, and finally the cloud computing. In this slide, the cloud computing is compared uh, with grid computing. You can compare these two types of distributed systems. Uh, the grid computing is for application oriented, but the cloud computing it's for service oriented. Okay, application and service. The cloud computing is the cloud computing uses the internet to present different services to the users. Okay, so the cloud computing is the infrastructure to present service to users. In another comparison, in the grid computing, the resources are distributed among different computing units for processing a single task. But in the cloud computing, the computing resources are managed centrally, and are placed over multiple server in clusters. Okay, another comparison: grids are generally owned and managed by an organization within a premise. Okay, so managed by an organization grid, but the closed server, the closed server consists of different servers around the world, owned by the infrastructure provided, and are placed in physically disparate location. Okay, this is another comparison. Because of these difference, uh, the cloud computing is more usual for the people, because okay, the people, the users around the world can connect to the internet. Okay, they can use the services which provided by cloud computing. Um, grid grid operates within a corporate network, operates within a corporate network, but about the cloud, it can also be accessed through the internet. Grid, it provides a shared pool of computing resources on an as needed basis. The grid consists of many resources which are shared by some organization. Okay, they can use all resources uh, are shared, all resources, all share between all users. Okay, so there is a pool of computer resources, and okay, the user can request to the manager to for a specific resource. Okay, the manager, the grid manager, find appropriate resource for the users. But about the cloud computing, it involves dealing with a common problem using number of computing resources. Involve dealing with a common problem using very number of computer resources. Okay, another and final comparison. Grid, it's a collection of interconnected computer and networks that can be called for large-scale processing task. Large-scale processing task. Okay, but cloud, more than one computer coordinate to resolve the problem together. Okay, in this slide, the grid computing and cloud computing are comprise and you can see them and check this. In cloud computing, distributed computing is presented as a utility. Okay, distributed resources uh, is presented as a commodity or utility. Okay, resources are provided by service supplier and effectively rented rather than owned by the end user. Yes, the cloud computing, the service supplier present the resources. Okay, they want to rent the resources to the users. And for example, the Google uh, consider a specific a limited resource for any users. For example, I don't know, for example, 15 uh, gigabyte, for example, for any email, for any file. But if you need more storage, okay, you must rent a storage. Okay, so end users when need more storage, okay, they must pay the cost for renting the storage. Okay, this is a way for service supplier to rent the resources. The term cloud computing captured the vision of computing as a utility. Yes, computing as a utility. Okay, these are some features of cloud computing. Okay, is it clear? Okay. Uh, uh, the services in the cloud computing are presented with different types. Okay, they can categorize in three classes: SaaS, PaaS, and IaaS. Some example for these services is Salesforce CRM, Lotus Leap as a service, as a SaaS service, or Google Application Engine as a PaaS service, and Amazon Web Services, Rackspace, Windows Azure as IaaS services. Okay, and the client can use the internet to connect to these services and use these services. Okay, after distributed computing system, distributed information system is introduced in the previous session. In this term, in advanced database, okay, or modern database is a type of distributed information systems because in this system the information is spread between some machines and the users can connect to different matches to use these services. One uh, important distributed information system is transaction processing systems. You know, the vast amounts of distributed systems in use today are forms of a traditional information system, but now integrate legacy systems. Okay, you can see one example of transaction process system. In this slide, this a simple example. Okay, the first sentence is begin transaction. Begin transaction on a server, and this is the name of transaction. Uh, the first statement is read some data from file 1, read the data from file 1. This data wants to write on the file 2, and okay, so I can say a copy of this data is stored in the file 2, and by using modify function the data is modified to the new data, and the new data is checked by the run function. If the data is correct, okay, if the data is correct, the new data can be stored, can be saved on the file too, by using the write function, write statement, and the transaction is end. But if the new data is wrong, okay, the transaction should be abort by using this statement, abort transaction. Abort transaction change the system state to the previous than this transaction. Okay, so all events that occur that happen in this transaction must be back to the previous state. Okay, this is the this is one. This is an important feature, important characteristics. One important characteristics of distributed information system and in the transaction process system. Okay, the transaction is a collection of operations. You see some operation, such as read, such as write, is a collection of operation on the state of an object. This object can be database or object composition, etc. that satisfy the following properties, which are called ACID. What are ACID properties? What do A, C, I, and D represent? Okay, in this slide you can see these properties. A is get from atomicity. This is one property of the transaction. Atomicity means all operations either success or all of them fail. All operations either success or all of them fail. When a transaction fails, the state of the object will remain unaffected by the transaction. Consistency is another property. A transaction establish a valid state transition. A transaction establish a valid state transition. This does exclude the possibility of invalid intermediate state during the transaction's execution. This does exclude the possibility of invalid intermediate state during the transaction executions. Isolation is another state. Concurrent transaction don't interfere with each other. Again, concurrent transaction. Some concurrent transaction can be executed in parallel. Okay, so these transactions don't interfere with each other. It appears to each transaction T that other transactions occur either before T or after T, but never both. And finally, final property is durability. After the execution of a transaction, its effects are made permanent. Change to state, survive failure. Okay, these are some important properties of transaction. Alaykum assalam. Hassan, because of internet connection and the bandwidth and the speed of internet connection. Uh, I use only the uh, sound and voice. Okay, so uh, I don't share uh, the image. Welcome, Hassan. Welcome. Um, uh, you know, uh, you know, in this term and in this course, uh, I'm going to talk about the distributed systems and the distributed databases. Okay, so now, the distributed database consists of matches, some matches, and data are spread between some matches. Okay, and okay, so we need to use a TP monitor. TP monitor is a transaction processing monitor, a specific module that manage the request. Okay, so you can see this figure. There are some matches and data are stored between some matches, between some servers. Okay, each client, when to use the data, appropriate data, the client must send the request to the TP monitor. TP monitor uh, manage the request, find appropriate appropriate server, and send the request to the selected server, which have the information, which have the data. Uh, okay, so TP monitor send the request to the server. Server reply the request, and TP monitor apply the client applications. Okay, so TP monitor is a module, is a uh, module which is responsible for coordinating the execution of a transaction. Sometimes uh, the data can be stored on some machines. Okay, so the TP monitor must get our uh, requested data from some matches and uh, concat and combine data and provide uh, all data and send reply to the client application. Okay, is it clear? Is it clear for all the students? Okay. Another distributed information system is enterprise application integration, uh, allowing existing application to directly existing application, client application and server-side application to directly exchange information using communication middleware by using this middleware. Middleware as a communication facilitator, enterprise application integration. Yes, this is the enterprise application integration consists of some applications which are connected through the communication middleware. They can exchange information, okay, by using this communication middleware. Alaikum assalam, Zia. And uh, finally, I'm going to talk about the sensor networks, which another distributed system. The sensor network consists of some nodes which are spread over some locations some time in the environment. Okay, the nodes to which the sensor are attached are many. These are some characteristics of sensor network. Consists of many nodes between tens to 1,000 nodes. These nodes are simple. They use a small memory, compute, and communication capacity, and often battery power or batteryless. A batteryless sensor gets its energy by stealing it from the environment. This is called energy harvesting. Okay, the wireless sensor network consists of many sensors in the environment. They can sense the environment and get data from the environment, and appropriate data must be sent to the base station. The base station get the information from all sensor nodes to manage. It's depend to the application in the base station. For example, in the jungle, the thermal sensor are spread over jungle, and when the temperature uh, increase from the threshold, uh, when the temperature is increased from the threshold, the sensor must be send the information to the base station. The base station get decision about this event. Okay, sometime. Okay, they need to get more information. Uh, okay, so this is one example of wireless sensor network, including a number of sensors that are used to collect data, and send them to the base station. Wireless sensor network. In wireless sensor network, The data can be sent by uh, some methods. Okay, uh, the continue the continuous method says data is always sent to the base station. In this state, the sensors are active. In query-based method, every time it needs, sense data is sent. It's called passive method. And event-based where a particular action occurs. So when a particular action occurs, the sense data is sent. It's called active. And hybrid method. In hybrid method, all send all information to the sink, okay, by different method. Okay, it can be used query-based or event-based method to send the data to the sink. Okay, also you can see uh, there are some different uh, mechanism which are used in WSN. For example, in the uh, above figure, uh, the sensor must be send information directly to the operator side to the base station. The sensor in this network has not storage, but in the figure below you can see each uh, sensor has a storage. Okay, so each sensor can process the data and store data. Okay, so in this state, when operator side send the query to the uh, sensors, okay, the sensor can send the store data to the base station. Do you consider aggregation of nodes? Do you consider aggregation of nodes? Yes, Omar, yes, because uh, I can say that the sync can aggregate all information, and also it can process all information, because uh, some decision sometimes related to the information which are obtained from some nodes, not only one node. And don't forget the node or the node in the WSN is uh, I wrote that they are uh, battery power or batteryless, or even batteryless. Okay, so they cannot uh, do the heavy process. They cannot do some heavy process. Okay, light process can be done by each sensor. Okay, so all sensors must send the data to the base station. Base station can can perform appropriate process, which can be heavy process to get decision about the whole system. Not okay. Okay, is it clear, Omar? Okay. Uh, could you get your response? Okay. And finally, the internet. The internet is the distributed systems. Okay, the internet. many uh, devices consisting desktop computer, mobile, server, and okay, different type of devices can connect it through this network. Uh, the different types of link, satellite link, I don't know, cable, wireless, okay, different, okay, the internet, many devices around the world can connect to each other, can get information, services. Okay, this is an important uh, distributed systems. Okay, so that's enough. Uh, if you any question about the distributed system, okay, I'm waiting to hear your question. Uh, if you have not any question, okay, we can finish this concept and start new concept. Any question? Okay, so I can stop and share another topic. One important challenge of okay, from now I want to talk about some challenge in advanced advanced database. Okay, so the one important challenge of advanced database is replication. You know, replication is important challenge of any distributed systems, any distributed system. Okay, so um, one distributed system is a distributed database. Okay, and I'm going to talk about the replication of this challenge of this in distributed database. Um, okay, I share this file, and also I'm going to send this file for you by using this. Okay, Paul, no file. Okay, I sent this file for you by this program. Uh, can you get? Uh, did you get this file? No? Okay. So I'm going to share this file through the Darsa, through the Darsa website for you. Okay, so please let me. company lessons advanced TV. Okay, I shared the replication. I uploaded the replication file in the Darsa website. Okay, you can download it now. Uh, okay, what is the replication? Replication means keeping a copy of the same data on multiple matches that are connected via the network. Yeah, no, you no, you know that a distributed database consists of some matches which are connected through the network. Okay, and in replications, some copy of the same data are stored on multiple matches. Okay, uh, why we use the replications? Uh, there are some reasons to keep data geographically close to your users, okay, to reduce latency. Uh, some programs, uh, for example, a supermarket chain. Okay, you know this program. Uh, these programs are used by several users uh, around around the city, around the country. Okay, sometime around the world, which with more distance to the okay, to the specific location. And so there are some matches, for example, over the city. Okay, and each user can connect to the nearest matches to use data. Uh, so to keep data geographically close to the users, we can use the replication. Another reason is to allow the system to continue working even if some of its parts have failed. This is another feature of the distributed systems, because you know distributed system consists of some matches. Okay, if one matching fail, the users can connect to the other matches. So okay, Omar's right that the file does not exist. Uh, are you sure? I uploaded the replication. I see the replication. Uh, please, other student, please check because Omar wrote that the file does not exist, but I think that the file is uploaded. Please check and declare us, please. Yes, PDF. Okay, okay. So Omar, you can download it because Ibrahim just right. I found the file application. Yes, the application file. Uh, okay, so another reason to use the application is to allow the system to continue working even if some of its parts have failed. Okay, it's used to increase availability of data. Uh, Another reason to use replication is to scale out the number of matches that can serve a read query. That can serve read query. You know, read and write query are queries which are executed on a database, but the read query can do by several matches by several users because they want to read information, but the write is can cause some challenge. Okay, so to scale out the number of matches that can serve read queries. Okay, by using this technique, we can increase the read throughput. Increase the read throughput. Uh, and another reason to use the replication is we assume that the database is so small. Okay, okay. Don't forget that in this course we use that the database is so small that each machine can hold a copy of entire database. Because sometimes the database is so huge and okay, they need to store on some matches because the information cannot store on one machine. But now I talk about the database which is so small that can hold can hold entirely of one machine on one machine. Okay. Different algorithms are present for replication. Uh, Popular algorithm for replicating change uh, use single leader, multi-leader, or leaderless. Can be uh, single leader, multi-leader, or leaderless. Okay, I'm going to talk about this. Uh, um, okay, let me to talk about this challenge. Uh, when we use the read query, when we use a read when any user in the advanced database wants to use the read query, is not important because uh, uh, the database entirely are stored on one machine, okay, and we know the database, some copies of database uh, are stored on some machines, and each read query can send to any of these machines, but one important challenge of replication is write query. When the data some data can wants to change by any user. Okay, some copies of the data are stored are any matches are some matches. Okay, and when a user wants to change one of these copies, other copies uh, uh, must be declared that the data change from, for example, A to B. Uh, some algorithms are presented for this, for replicating change, for this challenge. Uh, they can categorize in three classes: single leader, multi-leader, and leaderless. Replication challenge. All of the difficulty in replication lies in handling change to replicated data. In handling change to replicated data. Okay, before continue this concept, uh, please let me to rest, for example, for 5 minutes. After that, inshallah, I will continue. Okay, please. Okay, are you agree with me? We can rest for some minutes, for example, for 5 minutes. After that, inshallah, I will continue this concept. Thank you. Okay. Uh, After some minute, I'm going to continue this concept replication challenge. I say you that in the replication, the data or the same copy of database are stored on some machines. Okay, so the right query when a right query is sent to one machine, okay, other machines might be must be declared from this change. Okay, so all of the difficulty in replication lies in handling change to replicated data. When one machine change data, this machine must send the information, this change to remaining machines. Replication of database is an old topic. From many years, previous years, talk about this challenge, and different algorithms are present for this challenge. The principles haven't changed since much since they were studied in 1970. Okay, so don't forget the principle haven't changed because the fundamental constraints of networks have remained the same. Okay, so the principle haven't changed. And many developers continue to assume for a long time that the database consists of just one node. Me and you and many developers around the world because of this challenge uh, assume for a long time that the database consists of just one node, and all data of a database uh, is stored is on the one node. But okay, for some applications, some program, uh, we know this is not correct, and we know uh, if we want to increase the performance of the system, we need to use some matchings. One important method to increase performance is to use distributed system and distributed databases. Uh, uh, okay, so there are there are there is a requirement to store the data on some matches. Okay, and a lot of and also there are a lot of misunderstanding, which which can cause eventual consistency. Uh, Eventual consistency. The consistency is I define the consistency uh, uh, in distributed systems when in the previous sessions. Uh, okay, we need to have the same data on all matches. The consistency must be happen, and an eventual consistency happen, but there is a time uh, uh, when the data on one machine change, okay, this information must be sent to all to other machines, and there is uh, we need appropriate time to declare our matching. This time, this distance time, this period of time can be long or short. Okay, it's depend to the application, but we need eventual consistency, and eventual consistency happen after a period of time. Ibrahim asks, keeping copy of the same data in multiple locations leads to higher storage and processor cost. Uh, Leads to higher storage, Ibrahim, yes, but it can increase the performance. In scalability, when the number of users increase over time, okay, uh, we need to increase the resources because by increasing the resources, we can we can uh, save, we can uh, maintain, uh, uh, let me uh, we can keep the performance effective. Yes, keep or maintain the performance effective. So we need to we should to uh, uh, store data on some matches because we want to maintain the performance effective. And this is one of the challenge. Yes, Brian, this is one of the challenge. Another challenge, but now the challenge is replication and when okay in the replication the consistency is a challenge for us. And Omar asked a doctor's question: repetition of database and the processing of copy data is there a solution for it? uh, okay, I think I must to uh, describe this challenge again. And the challenge is consistency. Okay, what is this challenge? Um, we have the same copy of some matches, same copy on some matches. Okay, when the data of one matching change, okay, other matching must be changed after that because we need to have the same data, not different data. Because okay, these data must be, for example, this data can be related to the bank. Okay, I uh, uh, I withdraw some money, uh, 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 some withdraw money from the bank from one location. Okay, this uh, information must be sent to other databases, other nodes, because uh, these data must be uh, decreased from my account, and I cannot uh, again uh, withdraw this. Uh, okay, I think is it clear for you? Yes? Oh, okay, okay. Thank you, thank you. Okay, one technique for you to provide the consistency is using one leader and some followers. Okay, it's called single leader technique. What's mean of leader and follower? Leader, uh, you know, first, what is a replica? Each node that store a copy of database is called replica. Yes, each node that store a copy of database is called replica. In leader-based replication, which is the most common solution, uh, one of the replica is designed the leader. One of the replica is designed the leader as a leader, and other replicas are known as follower. Other replicas are known as followers. Okay, so when we want to when a write query wants to execute when a write query wants to execute on the database, this query must be sent to leader uh, node. Okay, and the leader node do execute the write query, and the leader node provide a replication log, or sometimes it is called the change stream, and this file, this information is sent to all of its followers. Okay, so I can say the read query can be executed by any nodes, by the follower or the leader, by the followers, any followers or leaders. By but the write query must be sent to the leader node, and the leader node, after executing the write query, the replication it must uh, create a replication log or change stream, and this log or change stream is sent to all of its followers. The client can query either the leader or any of the followers. Yes, we know that, but uh, the leader, but the write query must be executed by the leader, and the appropriate information must be sent to all of his followers. But the write query can be executed by any follower. This technique used in relational database such as Oracle, Data Quad, SQL Server, MySQL, and also in non-relational database such as MongoDB and Espresso, sorry. Uh, okay, is it clear? Any question about this slide, about this method? Okay. Uh, this figure shows the leader base or master stable application. you can see, for example, user 1234 wants to configure new profile picture. Okay, so this is the right query. This query should be sent to the leader replica. Okay, what is the query? The user wants to update users. This is one table that set a new picture for the user 1234. This query is sent to the leader replica. Okay, leader replica execute this query and create a data stream consisting this information: tables users, primary key 1234, which is the primary key of this user, and column. And this is a feature wants to change is picture URL, and the old value is me.me dash old.jpg. Okay, in this data stream, the leader wants to change the new value instead of old value for this column. And okay, this is the number of transactions. This data stream is sent to the followers, all followers. Okay, and the follower or replica execute this stream, this replication log on the data which are stored on them. Okay, so if any other users wants to read this the latest information, the users, for example, user 2345, send the query, send the read-only query to read-only query can send to any followers. Okay, this query is sent to this follower, and the user wants to select a star information from the users from this table where the user ID is 1234. Okay, so the user 2345 wants to see the all information of this user 1234. Okay, you know the picture of this user is changed, and the user 2345 can see the latest information by this technique. Okay, is it clear for you? Any question? Any information? Oh, okay. Uh, and another, you can in this figure you can see that there are two methods for replication in leader based replication. The replication can be synchronous or asynchronous. In synchronous replication, when okay, you can see the user 1234 send the right query to the leader, and the leader okay change the data according to this query, and before send the okay for the user that say to the user that your query is done. Before that, for a synchronous follower, the data change must be sent, and wait leader wait to receive the acknowledge from the synchronous follower. Okay, so the leader after change the information, send the data change, send the replication log to the synchronous follower, and waiting for followers, okay, for synchronous follower, okay, and after that, after receiving the acknowledge or okay from the synchronous follower, the leader send the okay for user 1 2 3 4. But uh, we know that the leader must be send the data change for asynchronous follower too. When the leader send the asynchronous the data for the data change for asynchronous follower, for example, in this figure, the follower 2 is asynchronous. When the leader send the data for asynchronous follower, uh, okay, it can continue its education, and it uh, it does not wait to receive the okay from the follower. Okay, before that, it can send the okay for the users, uh, and okay, sometime this change uh, can be happen, but after sometimes. Oh, okay. This is another method. In the first method, synchronous follower uh, uh, can decrease may decrease the performance of the system, but asynchronous follower uh, uh, don't affect the performance of leader, but there are okay it maybe there are some there exists some period of time that the data on leader can be different from the followers. Okay, it's called inconsistency, and so I can say some period of time it's possible to there are some inconsistency between the asynchronous follower and the leader, but the leader and synchronous follower are consistent in all times, because before confirm the the query from the users, the leader before that the leader send the data change for the follower, and wait to receive the information. We need to review the lecture to understand more. Yes, Ibrahim. Yes, Ibrahim. And inshallah, in the next session, I will continue this concept. If you need, we can explain more. Okay, that's enough for today. If you have any question, I'm waiting. If you don't have, okay, we can finish this lecture today. Inshallah, in the next week, I will continue this lecture. You're welcome. Okay, have a good day. Bye for now. Inshallah. Thank you so much, and bye for now.